This is Britt Caswell with another example video. In today's video, I'm covering example 4 from section 6-3 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to evaluate common and natural logarithms. So first, we should probably define those for you, shouldn't we? So, a common log is simply a logarithm with the base 10. Alright, so we are often lazy as mathematicians, and we don't like putting extra little notations and stuff like that. So if ever you see the word log and they don't put a number here, just assume it's 10. And so we call that a common log. Now you guys probably remember me talking about Euler and how I don't like Euler because he named everything after himself. Well, what can I say? Euler also named a logarithm after himself. This is called the natural logarithm. Natural logarithm is written with an ln. So understand that is an ln. That is not an I. I assigned this to my students and I got a ton of people telling me that was an I. No, that's an ln. Natural log, so logarithmic natural. And so the natural log is just the log with the base e. So we write a natural log when we're dealing with that log base e just so that we're aware that we're dealing with that e. All the other rules of logarithms apply to it, okay? It is just another logarithm. It just has a funny little look to it. Now understand, you will never use a natural log with anything other than e. Okay? So here we go. Now, this set of problems is really just making sure that you know how to plug into your calculator. So what I recommend doing is making sure that whatever calculator you use for your work, for your test, for whatever, that you're getting the same values that I'm getting. Okay? So this tells you what is the value of the logarithmic expression to the nearest 10,000th. So the 10,000th would be 4 decimal places. So another key thing here is making sure that you're rounding properly. Now, depending on what calculator you have, the order in which you type the 900 and the log here kind of determines, it depends on your calculator. So I'm using, for this video, this little junky calculator that's on my computer. You can't see it, but it's just the one that comes with Windows. So on that one, and on my iPhone, I have to type the number in the logarithm and then hit the log button. Now understand, you want to look at which log button you're using on your calculator, because there's probably 3 of them. One of them's a natural log, one of them's the common log, and then one probably will say something like log base y, or they might say log y of x. I've seen that as well. Those are allowing you for other bases. Okay. In this video, we're just using either the log or the natural log button. Okay, so the log of 900 is about 2.9542. And that kind of seems reasonable, doesn't it? Because log is base 10, right? So 10 squared is 100, and 10 cubed is 1,000. So if I'm looking at 900, that's closer to 1,000 than 100, right? So whatever logarithm, whatever power, should be closer to 3 than 2. So that kind of helps you mentally check yourself, if that helps. Now the natural log of e, this is another one that's kind of a big deal. If you plug that in, you get the number 1. So when I do math problems with students, and I'm solving equations with logarithms in them, and I see a natural log of e, I get so excited because that's just the number 1. Now remember, natural logs, I said, work the exact same way as normal logarithms. So here, where I have a natural log that has a negative inside, that's undefined. Because remember, you can't have a 0 or a negative inside of a logarithm. So now I'm coming to the try it. So the logarithm of 321 is 2.5065. And again, that makes sense, right? Because this is log base 10. 321, it's somewhat near the middle between 100 and 1,000. Not quite. It's a little closer to the 2 than the 3. But see, the number is between 2 and 3 here for my logarithm. Okay? So now the natural log of 1215. Another thing worth noting is that often calculators don't like commas. So I think if you go to put this on Desmos, you might have issues if you put the comma on there. Now the actual number my calculator is showing me is 7.10249935. It goes on for forever. But notice I rounded the 4 to a 5 when I truncated. So make sure that you're following your rounding rules on these. Otherwise you end up being a little bit in hot water. Alright, so now our last one, the 0.17. I get a negative 0.7696. And again, I had to round that one. Now you're wondering, but miss, negatives in logarithms are bad. Remember, if it's coming out of the logarithm, it's probably fine. Notice this is a common log, right? So we're looking at 10 with some different powers. And it turned into a decimal. So whenever something turned into a decimal from a whole number, or a fraction from a whole number, that's where you get that negative answer for your logarithm. So there we have it, guys. That's how to evaluate common and natural logarithms. Until next time.